In this part, we will take a sample question and answer regarding the chemical reaction rate. 20 centimeter cube of hydrochloric acid concentration 1 mole per decimeter cube was added to 20 gram of calcium carbonate, which is a large pieces, in a conical flask. The mass of the flask and the chemical was measured every minute. The mass decreased as the carbon dioxide scale. So for any questions, to solve the question, we first need to write the equation, and we have to make sure the equation is balanced correctly. Okay, so we have calcium carbonate, hydrochloric acids react together to give me calcium chloride, carbon dioxide, H2O. Okay, so after balancing the equation, we can start solving the questions. The first question is, calculate the number of mole of calcium carbonate and hydrochloric acids to show that the hydrochloric acids was the limiting agent, the limiting reagent. So as we know that the equations say concentration equal number of mole divided by the volume. Okay, and the volume here must be in decimeter cube. Okay, so let's start by, for example, hydrochloric acids. The mole of hydrochloric acids, or the number of mole of hydrochloric acids, is unknown, but we have the concentration and we have the volume. The concentration is 1 mole per decimeter cube and the volume is 20 centimeter cube. What we will do, we have to transfer this centimeter cube into decimeter cube first. 20 centimeter cube into decimeter cube, we will transfer it by dividing into 1000. 20 divided by 1000, it give me 0.02. This is the volume, the new volume. So we will multiply this 0.02 by 1 mole per decimeter cube. It will give me the number of mole. So here at the model answer, 20 divided by 1000 multiplied by 1, it gives me 0.02. This is the number of mole. The number of mole of calcium carbonate, how can we calculate it? Let's go through what's given regarding the calcium carbonate. It's given the weight or the mass, which is 20 gram. And as we know, the number of mole equal the mass divided by the molecular mass. The mass of calcium carbonate is 20, it's already given. Regarding the molecular mass, how can we calculate it? We calculate the molecular mass from the periodic table. Calciums, what's the calciums, carbons and oxygen? We add them together. The molecular mass of calcium carbonate, as we know, it's 100. And then we divide the 20 by 100. The answer is 0.2. This is the number of mole of calcium carbonate. So all the acid is used. That's why hydrochloric acid is the limiting reagent. Question number B. The reaction rate, mass of carbon dioxide, time is the slope of the curve. Why does this rate decrease within the time? So as we know that the concentrations of the acid is decreasing. Why the concentration of the acid is decreasing? Because the acid is used. The acid is reacting with calcium carbonate. So that's why in question B, the reaction rate or the mass of carbon dioxide, it's the slope of the curve. Why it's the slope? Because the concentration of the acid is decreasing. For question number C, how and why would the graph differ if the experiment was repeating using 20 gram of smaller pieces? Here we use 20 gram of larger pieces, but here we will use 20 gram of smaller pieces. What's the difference? The difference, as we study in the chemical reactions rate, as we use smaller pieces, this means more surface area. This means the rate of the reaction will increase. So what will happen? The rate of the reactions will increase because of the surface area is increased. Bigger surface area, so the rate of the reaction will be faster. In question number D, how would the graph differ if the experiment was repeated using 20 centimeter cube of hydrochloric acid of concentrations of 2 mole per decimeters cube? What's happening here? We double the concentration. We use 2 mole per decimeter cube instead of 1 mole of decimeters cube. So as we study, as we increase the concentrations, the chemical reaction rate will increase. So what will happen to the graph? The rate of the reactions will decrease, or we can say that the reaction will occur in less time. So maybe the first plot of the graph of the reactions will be like this. Take more time. For the second one, it will take less time because the rate of the reactions is increased. Gonna be like this. So doubling the concentrations of the acids will twice the rate of the reaction, will make the rate of the reaction faster. So if the first reaction occur in 2 minutes, the second reactions will occur in only 1 minute.